Hey, so just real quick, we're going to go over question 25. It's a little bit tricky, but it's not too bad. You just have to kind of go step by step. So we have a function right here. They're asking us to find h double prime. So we have regular h, we want h double prime. So first I have to find h prime of x. That is going to require for me to do the chain rule because I have f of and then g of x inside my f function. So when I take the derivative for chain rule, okay, remember that I'm going to need to keep my outside function's derivative, f prime, but the core has to stay the same. So my g of x from here is my g of x here, but then I need to multiply by the derivative of that, and the derivative of g of x is g prime. Now, if you wanted to go one more layer, this is an x inside that, but the derivative of x is really a times 1, so I'm not even going to put it. Okay, this is h prime. We need h double prime. And in order for me to find h double prime, I'm going to have to do the product rule. Okay, so that's where this can get a little bit messy. Not too bad, but a little bit. So, when I break this guy up for my product rule, okay, I'm going to do it down here just because I write really big. So, my u is going to be f prime of g of x, and my v is going to be g prime of x. So I'm basically just breaking these two pieces apart, then we're going to take the derivative of each one. Now let's do v prime first, just because that's going to be easier. So g prime of x, the derivative of that is g double prime of x. Then also keep in mind, derivative of the core x is just times 1. You can put it or not, up to you. Okay, on this side, u prime. My outside function is f. The derivative of f is f double prime. And then in the middle, I had a g of x. Remember, that has to stay the same. And then I'll times by the derivative. Now, if this is a g of x, the derivative of that would be g prime of x. Then from there, I'm going to write my product rule, and I'm going to do it up here. So, first diagonal that I'm going to put is this one. So I have f double prime with a g of x inside times g prime of x, and then times g prime of x again. So I have 1 here and 1 here. Plus, then I write my second diagonal would be here, and so it's f prime of g of x, and then g double prime of x. Okay, so from there we're looking at answer choices. I know I have an f double prime g of x, so it looks like all of them have that, but then I also need a g prime behind it. So this guy's out, that's only a g double prime. Okay, now why does this one say g double prime squared? Well, if I have 1 here and 1 here, it makes sense that they squared it, but they're missing this whole second part, so C is not going to work either. Out of my remaining 2 answers, this one has the f double prime of g, but it only has g prime once. I need to have it twice. So my answer has to be A. Notice, though, that this term here, the g prime of x squared, that's counting as the g prime of x and then the other g prime of x. So that's why it's a squared on there. Okay? Alright, there are 2 more questions that I'm going to do. I'm going to try to do them pretty quick. So take a look at number 32 at the bottom of this page. So 32 is here. If I'm taking the derivative of this guy, I have limit, I'm just going to write it bigger here, x approach 0, and then it says f of x minus f of 0 over x squared. Now notice, they give me f of x right here. So I'm going to rewrite that as the limit x approach 0, and then f of x is just going to be this, so 2x squared plus 1. Minus. Now, I need to find f of 0. Well, think about it. F of 0 just means I'm going to plug 0 into this. So if I want f of 0, that's 2 times 0 squared plus 1. So really, that's just 0 plus 1, which is 1. So if I want a minus f of 0, which is 1, then I'm going to put a minus 1 all over x squared. So this is f of x. This is f of 0. And notice that the minus is there because there's a minus here. Okay, from there, you should notice that 1 minus 1 is going to cross out. Okay, bye. And then what's left over is the limit as x approach 0 of 2x squared over x squared. And notice that your x squareds then, I notice those can cross out. Well, then the only thing that's left is 2. So answer choice C. Okay? Now, also notice that that kind of is in a weird spot because it's not really a definition of a derivative, but it's kind of in that section, even though it's not one of those. Okay? All right, last question we're going to do together. Take a look for me, please, if you will, at this one. Okay, at the top, number 18. So number 18 asks you to find the fourth derivative. So I have f of x here is 2x plus 1 to the fourth. So let's find f prime of x, and the second, third, and fourth derivatives. So f prime of x, I'm going to take the 4, times it down to the front. 2x plus 1, it used to be the fourth, now it's only to the third. But I need to times by the derivative of my core, which is a times 2. And then I'm like, oh wait, well 4 and 2, that's really just an 8 2x plus 1 cubed. Okay, from there we need to take the derivative again. So if I want f double prime of x, I'm going to take my 3, times it down on my 8. 3 times 8 in the front is a 24. My core stays the same, still a 2x plus 1. It was cubed, now it's squared. But then my derivative of the middle of that core is a times 2. Then I would be like, oh, well, I'm not going to leave these separate, so 24 times 2, that's really a 48. 2x plus 1 squared. So that's my second derivative. Okay, remember, we need the fourth derivative, so we're not done. Taking the derivative again, f triple prime. Okay, I'm going to take my 2 from the top. I'm going to times it down on my 48. 48 times 2, that's going to give me 96 in the front. Then my 2x plus 1 is still my core. It used to be squared, now it's only to the first power. But then I still have to times by the derivative of the middle. So I times my 2 down, reduce it to a 1, then times by the derivative of the middle, which is a times 2. Then I'm going to do 96 times 2. That's going to give me 192. Now, notice at this point, when it's a power of 1, I don't really have to put anything here. So when I go to take the derivative again, okay, I want you to kind of think creatively. This is the whole reason we're doing this one. My fourth derivative, 1, 2, 3, 4. If I want to do the chain rule, I can, right? I can put the 1 here, blah, 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 do all the things. But if I can avoid chain rule, I'm going to do it. So rather than me leaving this as a chain rule, I'm just going to distribute my 192 in. Okay, and then that distributing is going to allow me, okay, when I distribute, I can avoid having to use chain rule at all. Now, I can only distribute because now it's an x to the 1. So 192 times 2 is going to give me 384x. And then 192 times 1 is a plus 192. Keep in mind that's f triple prime. So if I wanted to take the derivative of that one more time, well, the derivative of 384x is just 384. And then the derivative of 192, since that's a constant, the derivative of that is 0. So 384 would be your answer. Okay? All right, you can do it. Good luck.